That's all right. Okay, so a four-person committee is to be elected from an organization's membership of 11 people. How many different committees are possible? Okay, so now we're just picking 4 people to be on a committee. We're not talking about different positions on the committee. There's no captain, co-captain, secretary, right? Like in the last question, right? So for the sake of the recording, we just saw a question where we had to pick 10 members, sorry, from 10 members. We had to choose 3 of them. Okay, so from 10, choose 3. And we had to pick a captain, a co-captain, a secretary. And what we said was that the first name that we gave you was the captain, the second name we gave you was the co-captain, the third name we gave you was the secretary, right? So what we did was we said, okay, there's 10 options for the first position, the captain. But as soon as you choose one, then you have to take one out of the running, so there's only 9 left. And then you have to take another one out of the running, so there's only 8 left. So that's a total of 720. Okay? We introduced the idea of the permutation, which is, fancy math to show that when we do 10 permutation 3, we get 10 times 9 times 8. Okay? So we're going to start at the highest value. We're going to go down a certain number of steps. How many steps? Well, how many choices are you making? Right? It's kind of the math. So what we recommended was we create these little slots, these little spots where we say, okay, this is the spot where the captain goes, this is the spot where the co-captain goes, this is the spot where the secretary goes. Making these questions visual is a really, really good trick. Okay? It's an easy one too. People often don't take advantage of it. Okay, so let's look at this one here. We do not have unique positions on the committee. Right? We just have a committee of 4. And how many do we have to choose from? So from 11 people, right, we're going to choose, and almost always it will make sense that this is the bigger number, this is the smaller number, right? So from 11 people, choose 4. Okay. So, and I'm even going to get rid of 11 people. I'm just going to say from 11, choose 4. Okay? And order matters or not? Does order matter or not? Okay, so let's do the kind of test case, right? So it's a so what we're talking about here is, somebody submitting the names forward of the, the people are named A, B, C, D, E, F, G here. So they put forward A, D, and G. And remember, we said that the first name that they give me is the captain, the second name is the co-captain, the third name is the secretary. Right? So when they give me ADG versus when they give me DAG, they've named different people as the captain and different people as the co-captain, right? Yeah, the secretary is the same, but these are different. So that's what I mean to say when I highlight different here, right? Okay, so those are different options. But here, if we're just talking about a volleyball team of 3 people, if you tell me that ADG are going to be on the court versus DAG are going to be on the court, well, though that's the same team. What are you talking about, right? That's not those aren't different ways, different combinations, right? So this here will give us slightly less options, right? Because now I kind of have taken away some options. ADG and DAG are the same. And so the math here is NPR, okay, National Public Radio. Here's what else you need to know today. That's my favorite part of that podcast. Okay, so NPR here is going to be n factorial over n minus r factorial, right? Which is going to kind of like, in the example, remember that was the 10 times 9 times 8, right? Just count down from the top, and however many counts you're going to do is the number of choices you're going to make. Well, here we're going to look very similar. It's going to actually have that same sort of story, but we have to divide by another value here, and it turns out that it's actually r factorial. And this makes sense. It has to be slightly less, right? So we have to divide by a value. Okay. So there we are. Okay, so for us, this here is where order doesn't matter, right? And this is where order matters, right? And that's our kind of dividing line, yeah? So, okay, so let's do it. So from 11, choose 4, order does not matter, which means it is n choose r, or 11 choose 4, right? Which means our n value is 11, our r value is 4. This is n factorial over n minus r factorial times r factorial. So let's do 11 factorial, that's our n, over n minus r, that's 11 minus 4 factorial. I know my 4 looks like a 9. Or I go too fast, okay. And then 4 factorial again on the bottom, right? So that really doesn't get any simpler. That's where that's coming from. But then this is 11 times 10 times 9 times 8. Now we've made 4 choices. The reason I stop there is, and I'm just going to write my 4 factorial here. So 4 times 3 times 2 times 1. Okay, so that's my 4 factorial. That I can't get rid of. But here, this is 11 minus 4 factorial, with this, which is 7 factorial. That's 7 times 6 times 5 times 4 times 3 times 2 times 1. Remember, the whole design, the whole trick is that that is there to cancel the sort of extras. We don't want to count all the way down from 11 because we're not going to take all 11. We're only going to take 4 of them. So we're going to count only the 4 steps. And then this will cancel with this, right? So those cancel. And so we're left with just 11 times 10 times 9 times 8. It's just big enough that I wouldn't really just do the division of the factorials, but your calculator has factorials as well. Okay. So we get that, and then we divide by 24, right? So the answer here is 330. So let's just do this. Okay, so the reason we have that r factorial is to account for multiples, because otherwise this would be way too high. Okay? Okay, so, boom, 330, right? That wasn't so bad. Okay, let's get it. Let's get spaghetti. Okay. It's time for some Vesgetti spaghetti. Okay. Okay, you want to get a cell phone, you must decide on the right plan. If there are 10 different phones, okay, so I'm kind of getting down my info. 10 phones, 6 calling plans. So 6 plans for calling, and 3 plans texting. Okay, sure. How many different plans can you pick from? If you can choose one phone, one call. Okay, so you can choose one of each. You probably have an intuition about this question, right? But let's use that intuition to develop a method for when we lose our intuition and it gets a little harder. Okay? So that's what us humans are good at. Alright, just taking a sip of my coffee here, I'll be right back. Seriously, bro. Seriously, you're gonna interrupt us like that? Okay. So, this, you could probably just tell what the option is here, right? So, let's say you have, our kind of 3 choices to make, right? Remember, this is going to be the same kind of methodology. How many choices do you have to make? I would recommend making that many squares, and then the number of options above each box, right? So for the first one, those are our phones. So I have 10 options, right? And then and then this is calling, and this is texting, right? And so let's say we are just choosing one phone, one calling, and one texting, right? Okay, but for now, the number of options we have for each spot, well, there are 6 options for calling, and there are 3 options for texting, right? Okay, so you might sort of have, your intuition might have already told you, it's just, you kind of multiply them, right? Let's think about the math behind that. Are they choices that are happening at the same time? So for example, does a certain occurrence, does a certain full plan put together, does it incorporate choosing one from the 10, one from the 6, one from the 3, or is it just one from the 10? And then another event, another occasion, another plan is choosing the calling, and another plan is choosing the texting. No, each plan is choosing all 3. So that's going to be kind of like one event, right? So that's what we mean by occurring concurrently, right? So, okay. So then let's follow through with this. If they're happening at the same time and they can, any variation of either of the 2 or any of the 3 can happen, then we're going to do multiplication, right? This is something that you do get a better instinct for, but these are, concurrent events in a certain occasion and are independent events, okay? But this is really just a counting problem. So our answer is 10 times 6 times 3, so 60 times 3, so 180, right? Okay, so there are 180 different plans. Now, let's say that it wasn't so simple. Let's keep the same number of phones, plans, and texting, but let's say, for example, that you were a sort of business. Okay, so let's modify this question a bit. Let's say that you are a business. You're a business. Whoa. Bus. I'm realizing I don't even know how to spell business. 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 I don't know, bro. How do you spell business? Buzziness. Bussiness. All this bussiness. Okay, it's just one of those words that just looks weird now. Okay. So, you're a business owner picking plans, multiple. Okay. So let's say you're picking for 4 phones. Okay. Let's say you're picking for 4 phones, and let's say that, okay, to make this a little bit simpler, let's say that instead of or a little bit more challenging rather, instead of just you can pick one phone, one type of calling, one type of texting with each of them, right? Because then it will just be kind of like 180 different options for each, right? And it would be interesting to sort of like ask about how many different combinations there are of the 4, right? Because you could have 4 on the same plan, or 2 of them on the same plan, and then 2 of them on the other same plan, or all 4 on that other plan, or whatever, right? Or you could also say they can't be on the same plan, they all have to be on different ones. We could multiply this question. What I'm doing is I want to say that we have 4 phones, okay? And they could kind of, they can kind of choose whatever they want, or really, each phone has access to all the calling plans that you pick. It's kind of like all the calling plans, they kind of like add up to be a new group. Okay? Let's say that they add up to be a new group. Okay? And so if you have one plan that's 100 minutes, another plan that's 200 minutes, whatever, of course it's not really how things work anymore, but let's say whatever, then you have total of 300 minutes, right? And all 4 phones can use that 300 minutes, okay? Or however much it adds up to. And same for texting, okay? But you only have 3 options for the texting, so you're gonna have to pick two of the same ones, right? Okay. So let's say that you're allowed to pick to add up 3 calling plans and 3 texting plans. To make a business plan. Okay? So, how many different business plans are there? So, what I want to do is I want to set up this question where we're not just choosing one of each, but we have 4 phones. We have a group of 4 phones on a group of 3 calling plans and a group of 3 texting plans. All right. So what we were asking before with this example was how many different ways can you choose 1 from 10? That's intuitive. That's nice and easy, right? So let's use that intuition to let's use that intuition, to our advantage when it's not 1. So let's say, for example, it was 2. How many different ways could you choose 2 different? Well, back to our example here, it's kind of like our 10 times 9 times 8, but instead it's just 10 times 9 because you're only picking 2. And the first one was 10, right? Which made sense. So the way I could pick 4 from 10 is 10 times 9 times 8 times 7, right? But then it will count those as different when I pick the 4 different phones, right? So this is maybe something that's a little bit of a detail of this question, but do the phones, does it matter? Is it just a team of phones and I have a group of phones on a table and every day somebody grabs a different phone, so it's not like the phones are assigned to the same people? Is that the case? Or is it that each phone is designated to each person so I can track when somebody's just using their phone like crazy, right? Well, it's probably going to be the latter, so we might do the first chunk different than we do the second 2 chunks. So let's do this where the order does matter, right? So in that case, it's going to be, well, we have 10 and 4, and we have to do 10, choose 4 of them, and we have to, the order matters, so that's a 10p4, right? Which is 10 factorial. So you actually have a NPR button on your calculator. So I'm going to do 10p4, and it's 5040. Right? So that's the number of different ways that you could kind of like pick those for, right? And this is 10p4, right? And so that's 540. And this here, well, does the order matter for the group of 3 calling plans that we just add up together? No, the order doesn't matter because when I add up 1 and 2, it's going to look the same as when I add up 2 and 1, right? Again, this is that sort of method here of looking at when I sort of like give you 2 different options that look very similar. Are they different or are they the same? That's how we tell if order matters, right? Okay, so then for my options, my calling plans here, it's not permutation, it's combination. It's, oh no, sorry, it's not 10. It's 6, choose 3, right? So 6, choose 3. This is a combination. So this is 6 combination 3. It's just 20. There are only 20 different variations there, right? And then what about texting? Well, this is just 3, choose 3. How many different ways can you choose 3 from a group of 3? Well, you're just going to have to pick all 3 of them, right? You can't repeat. There's not, well, that's another question. Can you get, can you repeat, right? In that case, it would just be 3 to the power of 3 because there's 3 options, right? If you have 3 options, and for the first slot you have 3 options, and then you could repeat, so it doesn't go down to 2 and then down to 1, right? Because that's like 3 factorial, right? But it actually just stays at 3 options, so that's 3 to the power of 3, right? And then we would actually have to divide by 3 factorial because of the groups being the same, right? But let's leave that. Let's just say we're doing this, and that's 3, choose 3 here, and that's 1. So the answer is actually 100,080 different, sorry, 100,800 different business plans if this was the setup. Okay, so in that case, we sort of, depending on if order matters or not, for each slot, we're going to sort of like have options and choose a certain number. Have options and choose a certain number, right? All right. Let's get it. Okay. So we're talking permutations. We're talking combinations. Let's do it. Let's just do this one fast. Okay. Test ready. So an election ballot asks voters. Wait, we're here, right? Yeah. An election ballot asks voters to select 3 city commissioners from a group of 6 candidates. Okay, so big question. We're picking 3 from 6. So from 6, choose 3, right? And just like the last questions, we've asked, does order matter? Does order matter? Are they unique positions, right? So if we need to, we can compare 2 sort of selections. So let's say we choose person A, person D, and person E. Is that different than person A, person E, person D? Right? It is not. Those are the same, right? So it's just a city commissioner, right? So order doesn't matter. So this is a combination, baby. 6, choose 3. 6 factorial over 6 minus 3 factorial over 3 factorial, so 6 times 5 times 4 over 3 times 2 times 1, which is just 20. Right? Boom. I think we got it. 20 ways. Alright, let's do it. Okay, last one. Let me take a little. We did the permutations, combinations. Time for a little StarCraft after this. 7 bands have volunteered to perform at a benefit concert, but there's only enough time for 4 of the bands to play. How many lineups are there? Okay, so 7 bands volunteered to perform at a benefit concert. So from 7, we're choosing 4, and then, wait, let's just kind of like be consistent here. Order, oh god. Order, not matter. Okay. Boom. So does order matter? That's the question, right? Well, I don't know. What do you think? For a lineup, what would you say? For a lineup. 7 bands have volunteered to perform at a benefit concert. That's nice. There's only enough time for 4 of them to perform. Okay. Do they have to do a full set? I mean, there's another solution here, right? How many lineups are possible? Okay, well, if you must have 4, each give them a proper half hour, little quarter EP, then they get what? I guess it would be different, right? If one band started and then another band finished versus vice versa, right? So one band starts, another finishes, and vice versa. Are they the same or different? The same or different, right? If one band starts and another band finishes, or vice versa, right? The first band finishes and then the other one starts. Yeah, that's a different lineup. So order matters. Order matters. So this is a permutation. 7 P 4. Right? So 7 factorial over 7 minus 4 factorial is 7 times 6 times 5 times 4, which is what? 42 times 20, so 840, right? Got it. Got it, Captain. Okay. We got it. Boom. Right? Okay. So, same as all the others, we sort of have to ask that same question where if I give you 2 different options and the order is a little different, does that matter? Would that be different? Okay, nice. Okay, we've alright. In a race in which 6 automobiles are entered and there are not ties, in how many ways can the first 4 finishers come in? Okay, so we should be able to catch it now. From 6, choose 4. Does order matter? E. No, E. What do we think? Does order matter or no? Does order matter or no? Yeah. Order matters. The order that you come in a race, right? So me telling you that the order, let's say that the racers are A, B, C, D, E, F. If I tell you that the order is A, B, D, F versus B, A, D, F, right? Those are different. So remember, that's the question we have to ask. That's what this big ugly thing is. We have to consider one versus the other. In this one, they're different. In this one, they're the same team, right? So we're doing a permutation because the order matters. So the permutation is now 6, permutation 4. The formula looks very similar. Does my last one? Oh, okay, yeah. But it doesn't have that extra r factorial. And so really it's just 6 times 5 times 4 times 3. Right? Another way to look at this, again, is our kind of like blocks method of who could have come in first, who could have come in second, who could have come in third, who could have come in fourth. Well, the number of options we have here before we have anybody winning the race, there are 6 options for who could win the race. But then as soon as somebody wins the race, that person can't also come in second, so there's 1 less. So there's 5 options for that. And then for the same reason, there's 4 options for coming in third. And for the same reason, there's 3 options for coming in fourth. Right? So that's what we're doing here. We're multiplying those values there. This is the math to get what we're looking for here. Right? So, boom. Okay, so what? 18 times 20? I think 3,600. Is that right? 6 PR. 6 P4. 360. Yeah, sorry. Got a little ahead of myself there. Yeah. Okay. What would you prefer to do, Prometheum? Sounds like maybe some chemistry? Premethane? Methium? Eum is chemistry, maybe? Could do some chemistry if you want. Let's do this last question to this. We'll take a little chest break or coding break or something. And I'll maybe grab some water and some food. And then... Oh, Promethium is the 61st element? That's gotta be some sort of joke. Is it? You want to talk Zerglings? I did try to play a game of StarCraft, but it didn't go so well. I don't know if the rig can handle it, but we can try it again. We can try it. Gonna try it. Okay, last one. To win the small county lottery, one must correctly select 3 numbers from 30 numbers. Okay, so select 3 from 30. This sounds like from 30, pick or choose 3. Okay. In order to when the selection is made, wait, the order in which the selection is made does not matter. How many different selections are possible? Okay, so they tell us directly. We don't even have to ask that question, right? And are there repeats allowed? I didn't start a podcast. Stop saying that. God, you're spreading rooms. Spreading roomies. Okay. So repeats are not allowed either. I can't pick the same number 3 times. 30, 30, 30, or 15, 15, 15. Right? Okay, so Promethium says not a joke. Ciphers elements Promethium. Very sneaky element. Extremely rare. Wow. Nice. I love it. I love it. Thank you for the fun fact. Right? I've got to write that down. Promethium, 61st element. So that puts it where? 61st is... So then... How many is after calcium? There's 10, 16 is 36. So it's somewhere in like the F block? Is that right? I'm just trying to base my memory. It's probably a poor idea. Okay, anyway, so repeats are not allowed. And the order doesn't matter, right? So this is a 30 choose 3 scenario. Boom. 30 factorial over 30 minus 3 factorial over 3 factorial. So 30 times 29 times 28 all over 3 times 2 times 1. Okay, wait, I'm gonna turn that music down just a smidge. Is that okay? Turn this up just a smidge. Okay. I like that levels a little better. Music not to right. You got that music. Look back to music. 4060. 4060 baby. Okay. Well, I did a 100 push-up challenge yesterday, so I'm not gonna do push-ups on our break, but I should do some form of physical exercise. I have been standing this whole time at my standy desky. Okay, Promethium, you're our guest of honor to choose it. What we got? A little yoga stretch, little jumpy jacks, little... You can request push-ups again. That would be cruel. My arms are sore, my pecs are sore, but we want to do a little something. Get the blood flowing. Right? 10 burps. Oh god. 10 burps. He wants the burps. Alright. Let's do it. Okay. And if you had to pick, would you say seal, raspberries, and ants, a forehead, onions, or tomatoes? Those are your choices. Give it to me. Give it to me. Give it to me. Raspberries and ants, a seal, a forehead, onions, or a stew. Tomato stew. No, you don't get a context. You just gotta choose it. No context allowed. Alright. It's more of a, I would say it's more of a tomato stew, but we'll allow it. We will allow it. You will allow it. Get right back to music. Okay. Boom. Okay. There it is.